Hi everyone, my name's Ethan and I'm going to be presenting LIGO today. So what exactly is LIGO? LIGO stands for Laser Interferometer Gravitational Wave Observatory. The picture on the right is what one of these LIGO labs looks like. I think this is the one in Washington. The LIGO program is fully funded by the National Science Foundation and run by both Caltech and MIT. The foundation funded the construction of two different LIGO locations, one in Hanford, Washington, and one in Livingston, Louisiana. At the time of construction, it cost the National Science Foundation nearly $400 million to build these observatories. The National Science Foundation spends about $45 million every year in operating costs for these facilities and their equipment. When needed, upgrades to LIGO's interferometer can be very expensive, ranging up to the tens of millions of dollars. Back in 2019, in one of the more recent upgrades, the NSF spent over $20 million on a major upgrade. Over the course of LIGO's lifetime, the National Science Foundation has spent over $1 billion on the project. Um, the National Science Foundation works to support the science community and keep America at the forefront of scientific discovery. And I think that's why they spent so much on the project. So much has gone into it financially because of how much the data collected from the project can expand our knowledge about the universe. These are the two locations. The one on the left is the Livingston, Louisiana location. The one on the right here is the Hanford, Washington one. I believe they're both um, very similar layouts, if not exactly the same. The interferometers at both are the same build. Now let's take a look into LIGO's mission statement. They want to quote, open the field of gravitational wave astrophysics through the direct detection of gravitational waves. LIGO is a national facility for gravitational wave research, providing opportunities for the broader scientific community to participate in detector development, observations, and data analysis, end quote. So basically, LIGO wants to use its observatories to aid in its own research, as well as to help the rest of the scientific community and astrophysicists with the data that it provides. Now let's take a deeper look into interferometry. Can never pronounce this right. Interferometry, interferometry, and gravitational waves. So, um, gravitational waves, as defined by NASA, are invisible yet incredibly fast ripples in space. They travel at very fast speeds, the speed of light actually, and these waves squeeze and stretch anything in their path as they pass by. These gravitational waves make space stretch in one direction and compress in a direction perpendicular to that one. So that's how these interferometers work. Um, interferometry is a process used to make measurements based on the interference of waves. That's where it gets its name from the interference aspect of it. How does this apply to LIGO? LIGO is a giant interferometer. Each arm in it stretches roughly 2.5 miles long. And basically, how it works is a laser is sent out from the start of it on the left side here. It's split into two, making an L shape, and then it comes back to the detector at the bottom. Um, when a wave is passing by, the arms of the interferometer are stretched and condensed back and forth, and this affects the alignment of the lasers, which makes them reflect into the detector. When there's no wave present or no wave is passing through, there's no change in the waves or the length of the arm and the wavelengths of the laser beams. So no light is reflected back into the detector.